Alright, so now we're going to talk about aluminum, and the main objective is to describe the main properties and uses of aluminum and its alloys. First, let's talk about aluminum versus iron. If you remember, iron, part of the processing was that iron would be reduced by carbon monoxide. Same process cannot be used for aluminum because aluminum is more reactive than iron, and it can't be reduced by carbon monoxide. Okay, and you can look at the electrode reduction potentials. The reduction of iron too might be a little difficult for carbon monoxide as well, but definitely not for iron 3. Hopefully you remember that the redox, the more positive the reduction potential, and keep in mind this is a oxidation, the more spontaneous it is. Okay. Alright, so some improved properties of aluminum over steel is aluminum has a lower density, has a higher thermal and electrical conductivity, it is more resistant to corrosion, and the alloys made with other metals are very strong. So let's talk a minute just at the corrosion resistance. The outer layer of aluminum typically will form an oxide layer, and that prevents further corrosion, further oxidation. So you get that layer and it stops reacting. And to take advantage of that oxide layer is a process known as anodizing. And this is, you can control that thickness of that oxide layer on the aluminum. What do we use aluminum for? Well, taking advantage of the low density, high strength of aluminum, we use it for aircraft bodies. We use copper as part of the alloy. Also used in aircraft parts and kitchen utensils. Okay, using magnesium as the alloy metal. Taking advantage of the low density, high electrical conductivity, overhead electrical cables are used or have aluminum in them. Low density corrosion resistance, foil for food packaging. And then the resistance to corrosion and high thermal conductivity is your cooking pans, pots and pans. Okay, so how do we produce aluminum? And specifically we're going to look at the electrolysis of alumina in molten cryolite. So the main source of aluminum again is an ore known as bauxite. It's aluminum hydrate, and impurities include iron oxide, titanium oxide, and sand silicon dioxide. Okay, there are 3 steps in purifying aluminum so that you can use it as a metal: purification, solvation, and electrolysis. In the purification step, we're going to separate the bauxite, the aluminum hydrate, from the iron, titanium, and silicon impurities. Bauxite is amphoteric, so it's going to react with the hydroxide ion in this equation. Okay. Then we can separate the aqueous aluminum hydroxide from impurities via filtration. And then you can reverse that reaction and reform the aluminum oxide. So anytime you can get something into an aqueous form where other things remain as solids, it's an easy separation process, filtering. Looking at it in a little closer detail, known as the Bayer process, you have your ore, you're going to crush it, mill it, pressurized vessel, heating it up, adding the sodium hydroxide, filtering out the impurities as solids. This is that salt, this is that aluminum hydroxide ion mentioned before. Cool that down, it's going to crystallize. Add some water. In order for it to crystallize, by the way, you do have to add some aluminum hydroxide into it. Water, put it in a dryer. That's what a kiln is. It's basically a big oven that rotates, and you end up with your aluminum oxide. The next thing is to dissolve that aluminum oxide in molten cryolite. why are we using molten cryolite, and why couldn't we just use it as an aqueous solution? Well, the mixture of aluminum oxide and I'm sure that has a special name, sodium 3 AlF6, has a lower melting point than the pure aluminum oxide, and that reduces production costs. Because remember, anytime you heat it up, it's going to cost money and energy to heat things up. Cryolite also improves the conductivity of the mixture, and that helps with that electrolysis step. Third step, the electrolysis. In the electrolysis of aluminum oxide, we have graphite anodes in the mixture of cryolite with the ore dissolved in that, and this is heated up to about 950 degrees Celsius, which is very hot. The graphite also lines the cell, and that is I'm hoping I said anodes for these. Did I say anodes? I'm hoping I did. I might not have. Those are the anodes. The cathode is actually the lining of the cell. Okay, and you have the steel and then the molten aluminum. And you have to have that graphite, that inert lining, because the steel, the metals in the steel would participate in the electrolysis. So your electrolysis happens and your molten aluminum comes out. Side reactions. The graphite sometimes becomes oxidized when oxygen is formed, and fluorine is also formed through the oxidation of the fluoride ion from the cryolite. Okay, so you have a couple side reactions going on as well. The reason why we can't do this in an aqueous system is because of the preferential reduction of the water as opposed to the aluminum. So we have to have a different system. Okay, so let's talk about the environmental effects of iron and aluminum production. All right, so now we're going to talk about both. We've got the mining of the ore. We have energy used during all the stages of the process. Remember, producing that energy causes some pollution. And then we also have the waste from the process. Looking specifically at iron production, remember that we're going to produce CO2, carbon monoxide, and sulfur dioxide. CO2 is a global warming compound, carbon monoxide is poisonous, and the sulfur dioxide is poisonous, and it also contributes to the acid rain. Those are all potentially released from the furnaces. CO2 and carbon monoxide is produced in the blast furnace itself. We do recycle this to use some of the heat, so that helps with the negative side effects. And then the gases from steelmaking furnaces are more difficult to prevent from being released to the atmosphere just because of the nature of the equipment. That slag that's produced in iron production is sold, although sometimes you make too much of it and they can't sell it. There's no market for it, so sometimes that gets dumped. That increases the landfill use. And then scrap iron is increasingly recycled, which is awesome because you have savings in cost and energy, and there is a reduction in pollution. If you look at the aluminum production, these are very high energy process, and that's due to that electrolysis step. Remember, keeping it up at 950 degrees Celsius, and also just the electric demand to run the electrolysis. The other components that those graphite electrodes and the cryolite need to be replaced every so often, and energy is used to produce those materials. Waste from the purification step is highly alkaline, because remember, we're using that hydroxide ion, and it's difficult to dispose of that. In addition, cryolite dust is toxic, and it's removed using wet scrubbers, but again, that's an additional process and additional cost associated with that. It does, however, by adding that step, minimize the pollution. Recycling. Best way to mitigate the environmental effects of aluminum production is to recycle. Aluminum recycling produces less than 5% of the carbon dioxide produced when making the aluminum from the bauxite ore.